Okay, this is 2.8 of algebra. Similar figures have the same shape, but not necessarily the same size. So here, these two triangles are similar. We use that squiggly to say that they're similar. So over here we have that triangle ABC is similar to triangle FGH. When I have similar triangles, their angles are always congruent, so their angles are equal. So angle B is congruent or equal to angle G. I can either go based off the pictures, so like A goes with F and C goes with H, or if I look at this guy right here, A is the first letter and F is the first letter, so those go together. B is the second letter, G is the second letter, so those angles go together. And then the sides are proportional. So if I look at side AB, that matches up with side FG. I can either go based off my picture, or again, I can look up at my similarity written. A, B are the first two letters. F and G are the first two letters. So A, B, and F, G go together. Okay, so if I look at these triangles and I'm trying to find DE, that guy right there, I want to find DE. I'm going to set a proportion using DE. The side that matches up with DE is AB. So DE over AB is equal to, and then I want to choose a pair of sides that both have numbers. I don't want to toss in another variable. I only want to have one variable. So if we look, EF and BC go together. I'm going to put EF on the top, and I'm going to put BC on the bottom because the bottom two need to be from one triangle, and the top two need to be from another triangle. These guys match up. Those are sides that match up, and these guys are sides that match up. So then if I plug in numbers, I get, so I don't know what DE is, so I'm calling that X. AB is 10. EF is 12. And BC is 16. If I need to, I can cross multiply. In this case, there's a shortcut. Remember, I can just multiply by 10. And those guys cancel off. And then I can multiply that out. 12 divided by 16 gives me 0.75 times 10. I get X is equal to 7.5. So the side DE is 7.5. I can do that same thing to find AC. So AC over, AC matches up with DF. And again, whatever I put on the other side, I want to have numbers for both of them. So I'll use BC and EF again. BC is going to go on the top because those need to be one triangle. And EF will go on the bottom. Okay, I don't know what AC is, so that's X. DF is 18. BC is 16. And EF is 12. Again, I don't need to cross multiply. I can cross multiply. Or my shortcut, I can just multiply by 18 since my X is on the top. 16 divided by 12 gives me 1.3 repeating times 18. X equals 24. So side AC is 24. Okay, same idea here, but now we're going to use a real life situation. So, I have a girl that has a shadow and I have a building that has a shadow. I'll put the shadows on one side and I'll put the heights on the other. I need to make sure that the girl goes on top and the building goes on the bottom, right? And this side needs to be talking about one side, so they're talking about the bottoms of these triangles. And this side right here is the height. That's talking about these sides that match up. You can read through that problem if you want to see it, but let's try doing our own got it problem. So a man who is 6 feet is standing next to a flagpole. Oops, we're going to go up here. The shadow of the man is 3.5 feet. The shadow of the flagpole, this is not proportional, or it's not to size. Sorry, my picture's a little off. But the shadow of the flagpole is 17.5, and I want to find the height of the flagpole. So I'm going to put the man's shadow, which is that bottom side. I need to match it up with the side on the flagpole, so that's also going to be the flagpole's shadow. Equals, remember I need to have the same triangles on the top. So if I have the man's shadow on top, I need to have the man's height on top as well. Over flagpole height. And then I can plug in. So the man's shadow is 3.5 over the flagpole shadow is 17.5. Man's height is 6 and the flagpole height is x. So in this case I do need to cross multiply because my variable's on the bottom. I get 3.5x is equal to 6 times 17.5. Oops, point. 0.5. 6 times 17.5 gives me 105. If I divide that by 3.5, I get that x is equal to 30. So the height of the building is 30 feet. Okay, a scale drawing is a drawing that is similar to an actual object or place. For example, blueprints or a map. And the ratio between the real thing and the fake thing is called the scale of the drawing. You don't need to have those definitions written down. So, in the bottom of my corner of my map here, I'm given that the scale is 1 inch with a colon, 110 miles. This means that 1 inch is equal to 110 miles. So, if we look at our got it problem, the distance from Jacksonville to Gainesville on the map is about 0.6 inches. What is the actual distance from Jacksonville to Gainesville? Okay, so 0.6 inches. I'm just going to do this the way we did 2 sections ago. Oops, not over x, sorry. Over 1. I want to get from inches to miles, so inches need to go on the bottom. Miles need to go on the top. 110 miles is 1 inch. My inches are going to cancel off. Multiply straight across. I get 660 over 1. So this is 660 miles. Oops, not 660. This is 0.6. Sorry. That's 66 miles. There we go. 66 miles. Forgot about my point there. A scale model is a 3-dimensional model that is similar to a 3-dimensional object. Again, you don't need the definition of this one. So there's a problem about a big, giant heart, if you want to read through that one. We're just going to do the got it problem. A scale model of a building is 6 inches tall. The scale of the model is 1 inch equals 50 feet. So again, I'm just going to do it the way that we did it a couple sections ago. 6 inch over 1. I want to get inches into feet, so I'm going to put inches on the bottom. 1 inch is 50 feet. My inches cancel off. And I multiply straight across, I get 300 feet. And there's your homework.